Alright, so this box at the top of 15.3 is just a nice quick review of when we have this equation, what does that D do? When it is greater than 0, we're going to go up. When it's less than 0, we're going to go down. So review from the last two lessons, that's our D. What about our C? When our C is minus, we're going to go to the right. When our C is added, we're going to go to the left. When our A, which is that lead coefficient, is greater than 1, it stretches. But when it's less, it compresses. And if it's negative, it's going to reflect. Okay, so that is a review from the last, from this whole week's lessons. Okay, so none of that should be new. It's nice to have it all in one little spot, though. All right, so let's look. Write an equation for a new function g of x, but describe the effects on the graph of the parent function f of x, x squared. So we have g of x is going to equal f of x. I'm going to replace this f of x. And I'm going to subtract 1 from it. So it's going to be x squared minus 1. So we're going to go down 1. This one, I'm adding 3 to my x. So I'm going to take my x plus 3 and square it, which means I'm going left 3 units. This one, I'm changing it to a negative, so it's going to be negative x squared, which means it's reflected over x-axis. Alright, here's my f of x. That's x squared. My a is 0.4, so I'm going to make it into its fraction, which is 2/5. So it's going to be a, which is 2/5, and my f of x, x squared. 2/5 is my lead coefficient, and it's less than 1, so it compresses by a factor of 2/5. All right, let's continue. We have a. Our a is 3, so it's going to be 3 f of x, which is our x squared, plus our d, and our d is 2. So we have a lead coefficient of 3 that's bigger than 1, so it's going to be stretched by a factor of 3. And then we're going to add 2, which means we're going to go up 2. Alright, so I want you to try 6 and 7 on your own. When you're done, I want you to pause the video, try them. When you're done, push play, and we're going to talk about them. Alright, so this one, f of x, we're going to minus c from it. So it's going to be, I'm going to take my x and I'm going to minus c, which was 4, and square it. And then I'm going to subtract 5. This means that I'm going to the right 4 and down 5. This one, we have an a, which a equals c, which equals d, which equals 4. So d equals 4, and c has to equal 4, then a has to equal 4. So we have 4 x minus our c, which is 4 squared, plus our d, which is 4. So we stretched by a factor of 4. We went right 4 and up 4. we have f of x, x squared, and they graphed g of x. So we're going to go ahead and graph our x squared, because I think that would be helpful. So our x squared always starts at 0 at origin. So if I plug in 1, it's going to, 1 squared is 1. Negative 1 squared is 1. 2 squared is 4. So 1, 2, 3, 4. 2 squared is 1, 2, 3, 4. And if we want to do the 3, we could. It goes all the way up to 9. And there is my x squared. Okay. So what happens here? Well, we had a reflection. Let's see if it grew any. So here's my vertex. If I go up 1 over 1, up 1 over 1, up 1 over 1, up 1, 2, 3, 4 over 2, 1, 2, 3, 4, 1, 2. I can see that my f of x is definitely bigger. So it got skinnier, which means it's stretched. I can see that it moved. It moved to the left 3. And I can also see that it went down 2. Ooh, lots of transformations there. So let's see if we can find the graph that matches it. So reflection means it has to have a negative in it. Well, that knocks out C and D. We know it had to be stretched, so there has to be a coefficient there. And left is adding 3, down is minus 2. B is the only one that matched. Let's look at number 9. Describe the transformation of the graph f of x, x squared, and that produces the graph g of x. Write the new equation and graph. So we have that f of x, we have a negative f of x, so x plus 4 squared. And we had it reflect, and it went left 4. So I'm going to take each coordinate, each part on that x squared, and I'm going to reflect it. So there's my x-axis right here. So it stays on the x-axis for my reflection and goes left 4. 1, 2, 3, 4. There's my new vertex. Take this point, reflect it over the x-axis. It's 1, 2, 3, 4 away, so it's going to be 1, 2, 3, 4 away. And then I'm going to go left 4. 1, 2, 3, 4. Take this point, flip it over the x-axis, and go left 4. 1, 2, 3, 4. And there is my, There is my new graph. The vertex is now negative 4, 0. And the axis of symmetry is x equals negative 4. Now this is as far as we went on in class on this. We're going to finish, 8th graders had a meeting, so they missed part of my class. So we're going to finish 10 and 11 on Monday on the homework day. But go ahead and try them on your own, and have a good day.